Hello everyone and welcome to re-entry. In this video I will be performing an SPS burn using the primary guidance and control system. And an SPS burn is basically a burn done by the Apollo Command and Service Module, which is basically this spacecraft you see in front of you now. And there's a big engine on the rear there which is kind of having this bell-shaped form. And that's the SPS, the Service Propulsion System. And this system is used to perform most of the burns in an Apollo mission. So to be able to control this engine, you will need to set up a couple of things. So if I jump into the cockpit, you can see that there's one central piece of equipment in the cockpit, which is the computer. And this computer is the interface that we are going to be using to perform the burn. So basically we are going to configure this computer with all of the burn parameters, and then we are going to execute the burn using the computer and only the computer. So this is going to be a fully automatic burn. In order to do that, we will need to know what our attitude of the spacecraft is and what this attitude is relative to. So the Apollo Command and Service Module basically have a set of gyros, an IMU, which contains a stable reference platform. And this stable reference platform can be changed throughout the mission. And the attitude you see here on the F-dice is basically your attitude relative to this platform. This platform is what kind of tells our spacecraft what's up and down, left, right, forward, and aft. So we are going to reconfigure our IMU. We are going to use the Apollo guidance computer to set up a Digital Autopilot to perform a burn more precisely. And then we are going to use auto maneuvering to let the computer guide the spacecraft into the correct attitude planned for this burn. So there's quite a lot of different things that we are going to look at, and I'll guide you through each and every one of them. But the first thing that we will need to do is to get the burn data. There's a couple of ways to do this. If I now take a look at my current orbit, we see that we are in an elliptical orbit of 114.1 nautical miles of altitude. That's the apogee. That's the highest point in my orbit. And then the lowest point, perigee, is 106.2 nautical miles of altitude. So what we're going to do is to perform an apogee burn that will raise our apogee by quite a lot. It's going to be a short burn, but we'll kind of take a look at the parameters soon. There's a couple of things that you can do, and that's the request pads. There's a couple of pads that you can do to plan a burn that should circulate your orbit at perigee or circulate your orbit at apogee. We are not going to circulate our orbit now. We are going to perform a simple burn at apogee. So then I'll set my ignition point to 180 degrees of, this is the phase. 0 is always perigee, 180 is always apogee. And then I'll set my delta V to 100 feet per second and prograde. And this will take us into an orbit of 162.3 nautical miles of altitude and 114.1 nautical miles of altitude in perigee. So we are basically going to raise our apogee. So we do have some data here. This is the time of ignition and the time to ignition and so on. But we are going to take a look at all of this data through the pad. So I'm going to hit request, and I will get a quick summary of the burn that I planned in addition to the entire pad. So I will go ahead and open the pad, and you can go into request pads, and on the top section you have forms, and then we have open P30 Maneuver PAD form. This is basically the pad that will be used for most of the SPS burns that we are doing in the mission. There's some rows of data here, but it all will make sense eventually, and I'll go through each and every one of them together with the system that they belong to, so you'll get a pretty good understanding of the most important part of the pad. So first of all, we have the purpose. The purpose is a simple maneuver burn. We use the maneuver planner to create it. So then I can use the pen tool. You can either click pen here, or you can use the scroll wheel to quickly go through a couple of the tools here. And then I'll just type maneuver in here. This is going to be a maneuver that I'm doing. It could be an AP circulation, perigee circulation, rendezvous, stuff like that. And then the propulsion system that we're going to be using is SPS. The Apollo command module got one other system that could be performing burns, and that's the RCS system, so basically translating in any direction. And our guidance system is going to be GNC. GNC, that's our primary guidance system, and that's mostly this computer here. The next piece of data is the weight of the spacecraft, and that's LBS, and we have 60215. And instead of me writing these numbers, I'll go ahead and use the stamp tool, and that's just using the scroll wheel, and I'm working on different ways to kind of quickly select which one you want. 2, 1, and then 5. That's our weight of the command module. The next piece of data is the pitch and yaw trim of our SPS engine, because it's a gimbal on the engine that allows it to perform some slight thrust vector control. It also needs a trim. So trim is set to 139 and 047. I'm working on this entire trim system, so if you want, you can look away from this data, as I'm automatically doing it behind the scenes, no matter what you do here. But eventually this will all be part of one simulated model or another. I don't know kind of what degree I want to do it in, but I'm doing some research around it. So all of this data here is used on a routine that configures our digital autopilot, and that's triggered by using verb 48. And we're going to do that pretty soon, but I'll just get through the entire pad first. You will notice that on, for example, weight, you have noun 47 and noun 48, and that's all part of, for example, the routine that gets called using verb 48. The next one is our ground elapsed time of ignition. That's basically the time of ignition in mission time. So if you take a look at the mission time, you see that we're 0 hours into mission, 53 minutes and 35 seconds. And our burn will happen at 1 hour. And I'll just fill everything in here. 001 and 19. And then 3400. And this got a special format, and this entire pad has been designed to be correctly formatted in the way that you plot things into the computer. So once you have a pad, you can very easily plot everything into the computer and set everything up by just following this data form. And it also shows you where there's a digit, because the AGC doesn't have a way to show decimals here. So you can see that in this string you have 00139, and there's a decimal between 1 and 3. So anyway, the next piece of data is plus 100. So I'll go ahead and say plus, and then 0, 1, 0, 0, 0. So that's 100.0. That's my required, or the delta V that I wish to perform at my local vertical. So this is relative to the local vertical. Plus 100 in the x-axis means that it's going through the spacecraft and out through the nose, so basically in the prograde direction. And the other ones are all 0. And lastly, on this section, it's the attitude, and that's also all 0s. This is the primary data for this burn. So basically it tells me that I want to perform a burn at this time, and I want the burn to happen with this delta V vector, and this is the attitude to perform the burn in. And if I do everything correctly, I should end up in an orbit of 1, and I'm looking at this data here, 162.3, 162.3, and then we had 114.1, 114.1. So the next piece of data here is the EMS and some data around the burn length. So first of all, I'm going to set our delta V, and then the time of our burn. That's the burn time, BT. That's 0, 0, 9. And then we have the delta V counter, and that's also 100. And this is what we are going to set into our delta V counter on the EMS here. And the next piece of data is our this alignment star. So we are saying that we want to verify our attitude with star number 4, and it should be at the given angle in the shaft in trinion. So if I now take a look at what this actually means, is if I now go ahead and toggle my seats and I jump down into my optics, I should be able to let me just also add configure everything for manual control, so I can move it myself. I'll just speed high, and then I'll jump into the optics, and I should now be able to maneuver around here, and I should see some stars. So I'll just move this out of the way a little bit. You can see that we have star 15, star 12, star 16, and by doing this, you will be able to figure out kind of what star the optics is looking at. So knowing those IDs, I can now hit back, and I can open up the map, and I can select stars, and it's saying me that the alignment star is 4. Then to find star number 4, we will go in and find it here. We can see number 4 is here, and star number 6 is there, and then next to them we should also see star 42 and 45. So through the optics, we can then use star 4 at these angles that we type in here to verify that star 4 is visible. Right now we are looking at star 15, star 12, and 11, and in this cluster here. So star 4 should then be visible closer to the burn. So now I'm going to I'm just going to skip going through this, and we are not going to perform anything related to entry, because this is not a deorbiting burn. So I'm just going to kind of skip this last section here. the other things that we do have is a set star, and that's 4 and 6, and this could be used to realign our IMUs using program 52 option 3. And then we have a backup GDC alignment platform if we want. I'm going to skip that for now. And then lastly, we have no on the large. So we're not going to basically press and hold this this button for a certain amount of time, or let it be done automatically. So this is basically our pad. It does have a lot of information, so we are now going to go ahead and set everything up. And I'm going to basically start from the top. So the first thing that we want to do is to open up verb 48, and just quickly a minor comment. On the checklist here, if you scroll a little bit down, you will be able to find a star list too, and this is the name and ID of all the stars that exists inside of the AGC memory. So these are the stars that could be used for alignment, just as a side note here. Anyways, I'm going to open verb 48, and there is a checklist for this, and I'm going to show you this now. Verb 48, Digital Autopilot data load. And I'm going to hit enter. And the first piece of data it requires is to know my configuration. And my configuration is CSM. So I'm going to use verb 21 and set this up to plus, say, 1. That's the CSM. I'm not connected with the LM, the S4B, or the Lunar Module Ascent stage. And I'm going to be using the thrusters, and I'm going to set the aero deadband to, for now, 1. That's 5 degrees. And then I can select the rate that I should reach as maximum rotation or angular rate to reach a given attitude. It should be 0.2 degrees per second. So that's quite a slow rotation. So I'm going to be helping it a little bit now in the interest of time. But the command and service module moved very slow to kind of save fuel. And then I'm going to just bypass the other one for now, and I'm going to hit Pro. And then it wants me to enter the weight. And that's something that we found here on the pad, and you notice noun 47. That also reflects the noun 47 here. So then I'm going to enter the weight of plus 60215, and I'm going to hit enter. And I'm going to bypass the lunar module weight here. It's not needed because I'm not connected to it. And the DAP knows about that because I selected the configuration 1 on the first register, A here. Okay, and with that set up, I can hit Pro, and now you can see 48, and this is basically the trim. So I can use verb 24 to set this, and that's 0, 0, 1, and then 0.39, and then 0, 0, 0, 4, 7. And there we go. And that's it. That's everything that we need to do in order to set up the DAP. And notice that I set the deadband to 5 degrees. So what that means is that it is going to try and keep my attitude within about 5 degrees. That's plus and minus. So it could be, going to be jumping up and down 5 degrees from the target. And next, we are going to set up our burn. So that's basically, let me get the pen here. This is basically verb 48. So the next piece of information here is verb 37, enter 30. That's major mode 30, program 30. And this data should be uplinked by the burn tool. but you could receive this data from elsewhere as well. Like if you request a APOC circularization burn, you need to plot this in yourself, or a pad from mission control, then you also need to plot this in yourself unless they do an uplink. So for now, I will verify that 1 hours 19:34. If I take a look at my mission time, we're now 1 hours into the mission here. And everything seems fine. That's now 33. And I'm going to hit Pro. And the next piece of data is our delta V, and that's now 81. You can see the same one here. And I'm going to use verb 25 to change all of this, and that's plus 0 and then 100.0. And then the next one is all 0, and the last one is all 0. And that's it to set up program 30. If I now hit Pro, the target orbit will get calculated. You can see that it will show me an orbit of 162.3. That's my predicted orbit if I do everything correctly. And then that's the apogee, and then 114.1 nautical miles in perigee. And I'm going to hit Pro, and then it's going to start counting down towards the burn. And I'm about 14 minutes away from the burn, so then I can hit Pro, and it should go back to 00, but I always usually do this. Verb 37 and 00 to enter POO. Okay, the next thing that we want to do is to set up our auto maneuvering. So this is basically the system that will try to maneuver us towards somewhere. But before I actually want to do that, I want to set the inertial platform. So I'm going to use 37 and program 52 to align the IMU with their burn direction. So I'm going to scroll down here to just show you this really quick. That's P52 IMU realign. And this one got a couple of options. So you need to select an option. That's noun 06, which is currently showing. You can see flashing verb 4, noun 06, and it requires me to enter an option. So the available options are 0, 1, that's the preferred. You have 2, which is nominal. 3, it's an IMU realignment, and then landing site. And we are going to use the preferred one. So then I will go and say verb 22 plus 1, enter, and Pro. And I need to verify that everything here is in inertial. The ordeal is set to off, and I can go ahead and hit Pro. And this will then align the FDI with relative to this platform. So my attitude is now this relative to the platform I set it. So now I can use verb 49 to call up the routine, which will allow me to set up the auto maneuvering. And there's a dedicated checklist for this as well. So if I just slowly scroll down, you will find verb 49, crew defined maneuver, and it will basically go through all of the information that this tool will have. But I'll just quickly show you how it works. So first of all, it wants me to set the desired attitude. So I'm going to use verb 25 here to just zero everything out and hit Pro. And now it wants me to, it asks the permission to maneuver towards this. So I will set the CMC mode to auto, and I'm going to hit Pro, and you will see that it now starts to maneuver towards this point. I have set the Digital Autopilot to move at about 0.2 degrees per second, so it will go quite slow. Next, I can hit Pro here to stop this, and we should now be all set up when it comes to the digital autopilot, the computer preparation. But one thing that I do want to do is to set up the EMS. So then I will go to delta V set, and I will set this to 100, and set this to delta V. And then I will try to remember to set this to normal when I get closer to ignition. So the next program I will need to run on the AGC is 40, and I can now close this. And remember that you always have access to your pads and mission comms through the transcript tab over there. So then I'll hit enter. The first one is that it's asking me to perform an auto maneuvering towards a set attitude. I have already kind of set that up, but this is another way to do that. I usually like to set that up ahead of P40. Next is trim. I will skip that, and then it's counting down towards the burn. So now I will quickly show you what I mean about the digital autopilot. So remember that I set it to 5 degrees. It will now reach kind of 5 degrees, and then it will kind of bounce back and forth. Eventually it will kind of tail off, but it will always be kind of within the 5-degree away from my target. So in order for that to kind of be more precise, now it will, you know, constantly glide a little bit. Then then I can go in here and I'll just hit warp 47, 00. Yeah. I broke it. Keyrel. Warp 37, enter 00. There we go. And what I will do now is to go to warp 49, and that's the wrong one. 48, I mean. Warp 48. And let me see. Did I mistype? So it's already set to 0, which means that it should stay within the target at 0.2 degrees precision, or 0.5 degrees precision. So let me just open up the checklist here, and the DAP load. And yeah, I've already set it to 0.5, so I'll go ahead and change this to plus 1, 1, 1, 1, 1. Enter. Now that you can hear that the digital autopilot kind of stopped working. That's because it now allows the attitude to drift out of its target attitude with plus or minus 5 degrees. So now it's going to kind of save fuel because it's not trying to compensate for its attitude drifting all the time. So during a burn, at least in most burns, you do want to have this quite precise, but when you're just kind of idling, then you might set it to off or to 5 degrees. So then I'll go ahead and just reset this one back to plus 1, 1, 1, 0, 1. And then you will notice that this one will then immediately start working again. Okay. Everything should now be set up, so I'll just redo the program 40. And we do have the countdown, 6 minutes left for the burn. So then I will timescale a little bit. There we go. 1 minute left to the burn, and I'm going to just help this a little bit. "59 seconds. There's a couple of important things to do and monitor when you are waiting for the ignition. So the first one is we will need to arm our SPS. And the second one is that we want to set this one to normal. And then during ignition, we want to see that these SPS engine injector valves are opening, that our fuel is being consumed, and that the SPS helium valves are closed. So now we're 19, 18, 17, 16 seconds away from the burn. At 35 seconds left until 30, this key will blank. And at 5 seconds, you see verb 99. We're going to hit Pro and then ignition. You can see that the valves are open. We're counting down. Valves are closed, open. And then we have the EMS. It tracked our delta V. And same with program 40. And if I now jump into my map view here, and I can also burn off the residuals using RCS. I did a little slight overburn. Now if I open the map view and then go to Earth, you should see something similar to our predicted orbit, which was 162.3 and 114.1. So it was a pretty good burn, and I can now go ahead and close program 40. Then I'm going to set the CMC mode to free and use verb 48 to once again just set everything here to 1 for now. And yeah, that's about it for performing an GNC controlled burn. What we did take a look at today was to quickly go through the pad. We saw that we used verb 48 to set up the DAP. We used program 30, there we go, to set up our burn. We use program 52 and verb 49 to set up our desired auto-maneuvering vector. And then we got a predicted orbit. We got some information that we configured the EMS with. And then we had star number 4, which we could use to align and verify our alignment if we had the auto kind of maneuvering on the optics. So yeah, there was quite a lot to it, a lot of information, but I hope that going through all of these details quite thoroughly is important for you to understand what's going on through an SPS burn. SPS burns, they're not easy, but once you kind of understand how everything is tied together and what systems kind of relate, then it becomes a lot easier. But I do know that it's quite brutal in terms of the systems involved. We have the RCS system that needs to work, the AGC needs to be configured, the Digital Autopilot, the IMUs and platform needs to be aligned, and then we need to execute the burn using the service propulsion system that should also be correctly configured and set up. So there's quite a lot to it. So I hope that this guide will help you kind of learn the basics of it. And good luck with all of your burns. If you do like these kinds of videos and these kinds of tutorials, please let me know in the comment section and hit that subscribe button. And hope to see you in the next video. Thank you.